Okay, the most suited, the most suited title of 2021 and 2020. You're on mute. Okay, let's go again. This time slot is dedicated to showing us PT Product Diagnostic Solution via noise inspection unit and how to enable product assessment testing. As well as we will get to the edge of product quality assessment by discovering product deviations as early as possible. Today with us, we have Jaime Moreno Terrazas and Tadej Teguetio Dimetric Armand, who are both working as data scientists at Bosch, and they're joining us from Germany today. Welcome to the stage. Hello, guys.
Yeah, thank you for the invitation. I'm glad to be here.
Yeah, the stage is yours.
Yep.
Thank you.
Okay, so let me go to the presentation. Or let's introduce myself. I'm working as a product development engineer in Bosch for power tools, and this is an exciting project to share with you guys all, and take it from here.
Thank you.
Yes, should I introduce myself also? Yes.
So it is
Hello,
loading still. Yeah.
Can you hear me?
Yes, yes.
Yes, then I can introduce myself. I'm Tada, working for Bosch since 10 years already, and I start on the automobile branch of the company, and since 2017 I'm working by Power Tools, which is a Bosch division, as data scientist on many topics, many projects, and inspection unit is one of them. And I'm quite happy to be here to share with you some knowledge.
Thank you. Tadej, just put it on the full screen, please, Jaime.
Okay. Full screen now. Okay, I think.
Awesome. Thanks.
I will go. Let's get it going. And I think we did a quick introduction already on the project. Is as we mentioned, is a product diagnostic solution for improving product as a whole. And let's go jump on the sense of it. And I'll start with three main areas that we kind of like this slide cover the picture, overall picture where we're going after. And there were motivations, challenges, and benefits of this project that we work on. All the way to the left, we start with the motivations. Taking it from the reality aspects of things are changing along the time, and they are not constant. And that fluctuation on components, processes, assemblies, anything that can be combined to make things not go the right way, that's what we don't know. And as you can see on the time domain, it goes and projects into deviations in our products. The challenges that we run into are a lot of questions all the time when things happen. And some of those questions are what changed? We never know. We have to investigate that. And how long has been this way? Don't know either. And most important is the impact to the user, how that is going to be in the user sense, and what will be the effect on them. And finally, we get into the cost that we're missing out. And finally, we get to fix it, right? And how do we do all those questions is a challenge. We go through those and waste a lot of time. That's where the benefits comes in. And those benefits are really the time they will take to find root causes and fix things and keep moving will be reduced. And the money also goes in line with that. But mostly an important one is relieving the employees that are inspecting our products daily. Is a tedious task and tiredness too. So the next I'll show you, we jump on the how we're trying to solve this problem, right? And we have a cloud-based infrastructure that we develop. Three main buckets here. The one on the left is the infrastructure to collect data. On the left, yeah, an inspection unit, the noise inspection unit. That's where it sits on, and it push data to the cloud, but also pull data from the cloud to do the machine learning connection to the back. And finally, the whole magic about machine learning and AI happens in the middle, using the infrastructure from different buckets from Azure, different solutions there. And at the right, we use a Power BI for dashboard presentation of data and further analysis of data and providing input to manufacturing and the different teams. I'm going to play a video. I don't know if the sound is going to come through, but we'll see. I'll explain it anyway. And this is how it's done right now, the manual process of inspecting our products. And let me play it, and you get to see. So this is a rejected tool that inspector is going to go ahead and take it out, hold it, feel it, kind of listen to it. She already classified it within seconds, right? There is a bad tool. Just going to go ahead and manually put in a label and say this is a bad tool, rejected. It's all manual process, and that's how it's right now. And the solution is to digitalize this process as much as possible. So from here, I'll pass it over to Collect Data to take over the AI and machine learning. Yes.
Yes, thank you, Jaime, for this part. Yes, I'm going to the next couple of slides, maybe 4 slides, to present to you the machine learning part of this project. As you know, all things start with data. So in our case, we are collecting some data at the end of the line. So as the image that or the video that you just see, the end of line operator taking the tool and start the tool, and then put on some box, which is as our noise inspection units box, and collecting the sound from there. So and at the end, sound look like what you are seeing here on the left side on the data side. So and after collecting the data, we go then to a process, which is here, like you see in the middle, is cycle. It's more general process, right? So starting from the data collection until the model building, and but in between we have some steps, like for example the data pre-processing. Why we have data pre-processing? Just because we are not saving just the sound of the tools, but also some meta information, because somehow we need to check the tool. We need also to regain the tool even if some issue occur. For example, in case of some bad tool, we need to know exactly where it was produced, the production line, and so on and so forth. And then the feature engineering, this is one of our, it's the most important part, I will say so, because as you may know, the model that you build at the end depend on the data that you feed your model with, right? So, and here is the part where we are in continuously improvement with the expert, because we want to build somehow the expert point of view, right? So you need to find feature which can then use to build this expert point of view. And then follow to this step, we have the pattern shares, or we can call that also like auto labeling, because it's nothing than a problem of outlier detection, right? And the reason why we went through this pattern shares is like, you know, we are producing a huge amount of the tool at the production line per day, right? So, and it's very difficult to let all those tools labeled by some experts or some operator. It's difficult because of cost, money, it's time consuming, much too many efforts, but this is also a stressful task, because if you want all those tools labeled by the people, then they need to take the tool all the time, listen the tool, and classify as good, marginal, and whatever, right? So, and this is a huge task and very difficult. So this is the reason why we decided to go through a process which can, let's say, be more automate, so we can then generate more label, and also not to use the human here, the human effort, the human power here. And here we are using, for example, as we will see in the next slide, so the auto encoder in order to build some kind of reconstruction error, and then based on that we can split the data in the 4 categories that you have. So at the end, after splitting the data, yes, we build then a model that we can deploy at the end of the production line. And at the production line is the next step is actionable insight. So basically we just use the model to decide whether the tool is good or not. In case the tool is classified as bad tool, then we need to find out what was the root cause, for example, and naturally, naturally also find out how we can then solve this problem, right? Please, can you move, Jaime, to the next slide? Here, basically here is the step of the model building. So as I say here, at the as input, we have our raw signal. We extract from the raw signal some data, and we have here in the classifier. This is a simple neuronal network that we built at the end, and then we can then classify the model good or not good. But also we have in between classes. For example, we have the margin, which is marginal, so we don't want just to say the tool is good or not, but we also want to say, okay, this is maybe near to the excellent or near to the bad one. And this is the reason why we have here 4 classes for this project. But in order to build a machine learning model, as I say, we need before that to have some to split the data, right? So, and this is next steps. The step before is then to split the data. This is then this next slide. I will say, I will explain you or will show you the picture how we split the data. So, correct. This is what you see, for example, here at the left side. This is our feature space, right? So, and our feature space, we have like I say, we built many features. Here you see, for example, a scatter plots of the loudness that we use as main feature, and also the sharpness. Those both are our main feature, but we also have other feature that we use, and we fit those feature into an autoencoder. You know, the principle of the autoencoder is like you take just imagine an image, you take an image, you fit into your net. At the end, you get also an image, but an image without noise, for example, right? So, and then you can build some a kind of reconstruction error on that image. And this is what we see, for example, the next is a reconstruction error. You see, for example, based on this feature space that was used to fit our autoencoder. At the end, we get exactly the same feature space. And then the reconstruction error is then the middle that we have to split our data. And the split technique here is just a simple box plot, because this is then one-dimensional array, and we can just use a box plot to split our data. And after splitting, this is the last graph is how the data look like after splitting. And the red is like our outlier, and then the yellow is our marginal, the blue our good tool, and the green represents here, for example, our excellent tool. And I will also show you the in the next slide, for example, the process, how this look like in the cloud. This is our pipeline that we have in the cloud. Basically, this is the steps that we have, starting from a global configuration, the auto labeling, and so on. And here you see, for example, also on the right side, again, the reconstruction error and how the plot look like. But you also have some output like the model history. We also show the history of the model, how the model performed to the data, and the confusion matrix. And you can see, for example, here, I cannot see well, but it's around 90% of F1 score based on the data that we use. And which is already pretty good for the use case. In this model is also used in production now. And the colleague Jaime will give you also some matrix and also some result that they gain at the end of the line life. Thanks.
All right. Thanks for that. And I'm taking it back. And this is as Tara mentioned, is where how do we challenge the model? And it comes down to the how do we validate a model? And it's taking physical samples from production. And in this case, we took 100 samples previously rejected by humans and inspectors, and we take it to the quality standard and do a secondary assessment on them. And we say, you know what, when we have this model, these tools rejected by humans, and now we have a true label from the quality standard. And the true label here is on the vertical left axis. And the machine learning performance in this case is the horizontal one. And we can see it does pretty good job on excellent and good and excellent and marginals. We're not too worried about the good ones because all of them are acceptable products between Excel, good, and marginals. Those become acceptable products. The ones that we are working on and worry the most is the one on the bad accuracy with 63. We're working on that 14.89% now. And what we're doing here is we're combining the human perception for those specific ones and further collect data on those so that we can feedback to the model and make a new model improvements and just keep doing it until we get minimize those rejections or bad classification from the model. We found that we're pretty comfortable right now combining humans and machine and to do to the next level on this exercise and this project. And I think we're succeeding so far with this project and this showcase. Next, I'll show you kind of a overall framework of how this solution came about, and it's a multi-domain. Obviously, it's a multi-domain approach, taking it from the different angles, all the way from product development, marketing, quality, production, people in production, what they're doing, and mainly the whole infrastructure on the digital side. All the way from on the blue domain here is the data collection, digitalizing data, cloud solutions, and visualization of data. That's what the domain is coming together. And the domain on the manufacturing side is in charge of implementing in production and defining the monitoring and trend checks, right, on the different outputs of the models, and finally making decisions out of the data. The green domain is the whole initiation of the product development, where they get insights, and we want to find a team that actually develop the specs, right? The standard for quality. And that's where it comes, that domain in charge, the product knowledge as a whole. So this is kind of the framework and the roles kind of the embedded inside of it in the left. That's kind of the summary of an approach to this problem. I think with this is the last slide, and I think we're ready for Q&A at the moment.
Thank you for a wonderful presentation. We have one question which is not really related to the presentation itself, but more to your role, Jaime. So, what is needed to become a product manager on the data science product or AI product? What's the
Okay. Very good question. Is really the self-development. That's the trigger. Really is coming from the mechanical engineering background in products and having a lot of history in product development. I decided to go to what is next in product performance and making things better. It triggered the machine learning is the solution that I found the most attractive personally, and that's really the trigger. Is getting to know something new and exciting, and machine learning AI seems to be the good fit. Yeah.
Okay, so that is the only question for now. I want to invite the audience to feel free to ask the questions. Don't be shy. And maybe Tada, you want to give the like a conclusion or some main points added to the presentation, like to wrap up or something like that. Okay, we have some kind of delay. Jaime, can you hear me?
Yeah, we can hear you.
Okay, so it's a frozen picture. Okay, because manufacturing is not really the space I'm like experienced with. I would love to ask you additional question, but maybe you would like to wrap up and tell to engineers your additional point of view related to presentation and what we just heard.
Kind of overall takeaway is it is a based on my experience on working on this type of project is a cannot be solved with one domain. That's the bottom line. You have to include multiple expertise, different angles, in order to come together into a solution. And that's kind of the sense at the end is how do we collaborate with others to make things happen. And that has been the most valuable experience. It's collaboration really with multiple domains, and feel comfortable of not knowing things. That's kind of
Collaboration and education. You're doing a great job in Bosch. So we had a presentation today related to your cycle, how you're onboarding new people. So it's really astonishing company culture.
yeah. Thanks.
Tadek, do you want some key points to add to the closing remarks?
No, I wanted to talk, but somehow I had some net issue. Sorry for that.
No, we can
no,
hear you.
The project is quite a very important, a very inspiring project, and this is one or maybe the first AI project that we did in our plan, so in our manufacturing line, and this project also become bigger and bigger, and yes, it's very nice. But what I want to emphasize here is also like we need starting in more generally, right? So when you start a machine learning project, so you need to think about an end-to-end solution, right? And at the beginning, it doesn't matter if it's not for automated, but and you need to for the starting already for the beginning to try to complete the chain, right? To put all the block together, so to have a chain that we can also uh, make some changes in quickly, faster, and so see also the results. And this is was also one of our main tasks here, how we can build a pipeline, end-to-end pipeline products to be able in very quick or in second or minutes to run some kind of model and test at the end of the line. So Jaime is sitting in Mexico, I'm in Germany, right? And so it's very important to have something like that. And now we are in the uh, status that we can run a very faster model and test at the production line. And this is one thing that from my experience, is very nice, very good, and which also makes this project somehow very important and motivating.
Okay, we have one question. When did you start working on this project?
Has been a while. Myself, I started 2.5 years ago with an initial understanding of sound of the products, and I got involved that right up from the beginning. And what it has been a couple of years already. From my side, 2.5. Yeah. That, what about from your side?
Yes, more or less. I mean, also, 2 years ago, I start also in the project, and yeah, we already did a lot. Still, this is new also by Bosch, also by Power Tool machine learning project, AI project, and this also had the consequence that people, there are some people they are a bit restrict, right? They don't want to approach the topic. We need somehow some psychological effect happen by the people, so that they say, okay, machine learning can do the job, right? Can classify the tool, and this is something big deal that we have now. But we are starting also. We are also in yes, in status that we can say, yes, people are starting and thinking about that machine learning can do the job, can also do more than just the job of the human, right? And this is also a very good feeling that we had the last week, and yeah, we're happy for that, and we hope that we will also move into this direction, because this is the way to go now. We are talking about how the data can change the world again, and then this is definitely the way to go. We're happy, and we push the topic all the time by Bosch.
Amazing. As we said at Data Science Conference, we can change the world through data. So I love that. And also thanks once again to Bosch for being our partner. And thank you for joining us today and sharing this valuable knowledge with the audience. We were really happy to have you here on stage.
Yep. Thank you very much for inviting us.
Thank you, Jaime and Tada. Enjoy the rest of the day.
You.
Thank you. Bye.
Enjoy.
Bye.
Bye.